Mars has long captivated our imagination. It's the stuff of science fiction dreams, a new frontier for humanity to conquer. But is it really a viable alternative to Earth? This question has sparked debates among scientists, engineers, and dreamers alike. The allure of Mars is undeniable. It's our cosmic next-door neighbor, with a day length similar to Earth's. Some even speculate it once harbored life. These factors make it seem like a potential new home for humanity, but appearances can be deceiving. The red planet presents challenges that make colonization a daunting task. From its harsh environment to logistical nightmares, Mars is far from a ready-made Earth 2.0. Let's start with the basics. Mars is cold. Really cold. The average temperature hovers around -63 degrees Celsius, or -81 degrees Fahrenheit. That's colder than Antarctica's lowest recorded temperature. Even at its warmest, Mars rarely gets above freezing. Imagine living in a world where your breath freezes instantly. Mars's atmosphere is incredibly thin, about 1% as dense as Earth's. This thin air can't retain heat well and offers little protection from the sun's harmful radiation. On Mars, you'd be constantly battling extreme temperature swings and dangerous UV exposure. Mars air is mostly carbon dioxide with very little oxygen. Any human settlement would need to create its own breathable air. This isn't just a matter of comfort, it's a matter of survival. Every breath would depend on complex life support systems. Mars is known for its global dust storms, which can last for months. They block out the sun and cover everything in fine, abrasive particles. These storms would pose serious risks to any human settlement. On Earth, we take many things for granted: the air we breathe, the pressure around us, and the protection from cosmic radiation. On Mars, each of these becomes a life-threatening challenge. The margin for error is razor thin. Mars's atmospheric pressure is less than 1% of Earth's at sea level. This low pressure has serious consequences. Liquid water boils at just 10 degrees Celsius or 50 degrees Fahrenheit on Mars. Your blood would literally boil if exposed to this environment. Any habitat would need to be pressurized, and a breach could be catastrophic. Earth's magnetic field and thick atmosphere protect us from cosmic rays. Mars lacks these defenses. Astronauts on Mars would be exposed to radiation levels 100 times higher than on Earth. This increases cancer risk significantly and could also cause cognitive problems and other health issues. Going outside would require a spacesuit. These suits are complex and can malfunction. A tear or a failed air supply could mean death in minutes. Every excursion would be a potentially life-threatening event. Water is life. On Earth, it's abundant. On Mars, it's scarce and hard to access. Most of Mars' water is frozen in its polar ice caps. The rest is likely mixed with soil as permafrost. Extracting and purifying this water would be energy-intensive and technologically challenging. Even if we could access Mars' water, we'd face another problem: contamination. Martian soil contains perchlorates. These are toxic chemicals that can cause thyroid problems. Any water extracted from Mars would need extensive purification. This adds another layer of complexity to an already difficult situation. Food production on Mars would be equally challenging. The soil isn't suitable for growing Earth plants. It lacks essential nutrients and is full of those toxic perchlorates. Any agriculture would need to be done in controlled environments. Mars receives about half the sunlight Earth does. Every calorie of food would come at a high energy cost. Section 5. The long journey and building a new world. Getting to Mars is half the battle. The journey takes about 7 months with current technology. That's 7 months in a confined space. 7 months exposed to cosmic radiation. 7 months of potential equipment failures or medical emergencies. The psychological toll of such a journey is immense. Astronauts would be isolated from Earth. Communication delays could be up to 20 minutes each way. They'd watch their home planet shrink to a tiny dot in space. The stress and isolation could lead to mental health issues. Once on Mars, the real work begins. Every structure needs to be airtight and pressurized. It needs to withstand temperature extremes and radiation, and it needs to be built using materials brought from Earth or manufactured on Mars. Manufacturing on Mars presents its own challenges. We'd need to develop new technologies to use Martian resources. This includes extracting oxygen from the CO2-rich atmosphere. Every step requires innovation and carries risks. Section 6. The human cost health risks on Mars. Living on Mars would take a toll on the human body. We've evolved to thrive in Earth's conditions. Mars is radically different. The low gravity alone poses significant health risks. In reduced gravity, bones lose density, muscles atrophy. The heart doesn't have to work as hard, leading to cardiovascular deconditioning. These effects are well documented from long-duration stays on the International Space Station, but at least astronauts on the ISS return to Earth. Martian settlers would face these challenges permanently. They might never be able to return to Earth's gravity without serious health consequences. The radiation exposure on Mars is another major health concern. It's not just about cancer risk. High radiation levels can damage the central nervous system. It can cause cognitive decline and increase the risk of neurodegenerative diseases. Protecting against this radiation is extremely difficult. Even with shielding, long-term exposure is inevitable. On Earth, we have access to hospitals, specialists, and advanced medical equipment. On Mars, medical resources would be limited. A serious injury or illness could be fatal. Section 7. Mind over Mars, Psychological Challenges. The psychological challenges of living on Mars are as daunting as the physical ones. Imagine living in a small, enclosed space. You can't go outside without a spacesuit. You're constantly aware that a single mistake could mean death. This environment would be incredibly stressful. Isolation is another major factor. Mars settlers would be cut off from Earth. They'd miss birthdays, weddings, and funerals. They'd never feel the sun on their skin or breathe fresh air again. This isolation can lead to depression, anxiety, and other mental health issues. The lack of privacy in a Mars settlement would add to the psychological strain. Living spaces would likely be cramped. Every resource, including air and water, would be carefully monitored. This constant surveillance, even if necessary, could feel oppressive over time. Section 8. Weighing the odds, Mars versus Earth. When we compare Mars to Earth, the contrast is stark. Earth has a breathable atmosphere, it has liquid water on its surface, it has a magnetic field that protects us from radiation. These are not small advantages, they're fundamental to our survival. Earth also has biodiversity. It has ecosystems that support life. It has resources we can use without complex technology. On Mars, every aspect of survival would need to be engineered. Every failure could be catastrophic. The margin for error on Earth is much wider. Moreover, the problems we face on Earth are solvable. Climate change, pollution, overpopulation, these are challenges we can address. They're difficult, yes, but they're far more manageable than terraforming an entire planet. The resources required to make Mars habitable could solve many of Earth's problems. Even the most ambitious Mars colonization plans involve a few thousand people. That's not a solution for humanity as a whole. Section 9. Looking to the stars, cherishing our home. So, where does this leave us? Should we abandon our dreams of Mars? Not at all. Mars exploration has value. It pushes our technological boundaries. It expands our scientific knowledge. It inspires us to look beyond our own world. These are worthy goals. But we need to be clear about what Mars exploration is and isn't. It's not an escape plan. It's not a replacement for Earth. It's a scientific endeavor, a stepping stone to understanding our place in the universe. We should pursue it with that perspective in mind. As we reach for the stars, we must also turn our gaze back to Earth. This planet is our home. It's the only place in the known universe perfectly suited for human life. We should cherish it, protect it, work to solve its problems rather than fleeing them.